GeoTrig, what we're doing today is starting our log. I'll call this a unit. A log unit, and it's basically combining lessons 26, 40, 59, and 98. And so we're going to start off with the lesson 26 material. And the lesson 26 material is pretty simple. On this lesson, all we're doing is switching from log form to exponential form. Okay? And I see that we lost the words on this one. And so this one, n equals b to the L, is our exponential form. And the other one, log base b of n equals L, is our logarithm form. These guys are interchangeable. That's why it has a double-headed arrow there. They can both mean the same thing. So the biggest thing that we need to worry about is our placement of those variables. Granted, our variables will become numbers at some point or different letters. So therefore, I need to understand that my base to some power will equal a number. Kind of means the same thing as log base b of n equals L. Now why does this work? That's because logs are exponents. And if you can think of it that way, when we get to the laws of logs, it's going to make a lot more sense as well. And so, notice that the base of our exponent and the base of our log are both b. B for base. But what changes is that you take n, which was our answer from the exponent, so we're taking log base b of n, is equal to L, and L was our exponent. So if I was going to switch out a log, I'd say b to the L power is equal to n. Or from over here, I'm going to take the log of base b of n, and that will equal L. So the first group of our homework is we're going to switch between the forms, and then we're going to solve some very simple log or exponential equations. Okay? So, left-hand column, I want you to switch to log form. The right-hand column, I want you to switch to exponential form. So we'll do the top ones each, and then I'll give you guys some time to figure out the rest of them. So, if I'm going to start here, the base is 3. So I'm going to take log base 3. Log base 3 of what it equals. So log base 3 of 4 is equal to the exponent y. Log base 3 of 4 is equal to y. It's a little different way of thinking. Log base 3 because the base of the exponent is 3, of 4 is equal to the exponent y. Those ones I think are a little bit more difficult than it would be going from log form to exponential. I think going from this form, log form to exponential, is actually easier. Because I'd say, hey, what's the base? To what it equals, to what's inside. So when I go here, I go x to the m equals 4. I think that's a little bit easier. X to the power of m is equal to 4. And notice that when we went here, 3 to the y is equal to 4. And that's how we switch there. That is n to the 1/3 power right here. 1/3. So, I'm going to give you guys a little bit of time. Try to get all 4 of those done. Okay, let's go to the second convert to logs. What would this log be? Log base n of 2 equals 1/3. Correct. Let's keep going down the column here. So this would be log base of 16 is equal to y. It's y, right. It's the exponent. Now, this is what I was trying to hint at while we were not recording, is that eventually, guys, you're going to be given this log. And it's going to say, solve for y. Well, which one do you think is easier? This log form or this exponential form? Can you guys tell me what y is?
Oh, well, I think the exponential would be easier.
Exponential is definitely easier, because what's y?
Y would be 2.
Y is 2. But guess what? Log base 4 of 16 is also 2. They mean the same thing, but I think exponential form would be easier to solve than this log form. So we're going to be given logs that we're going to have to switch out to exponent form, and make it easier to solve. Now, moving over here, let's switch this to exponent.
Okay, oh, what we did. So 2/3.
2 to the
Power of
3 equals n. And?
E to the second equals 4.
Equals 4. Hey, do you know what p is?
Yeah, we do. It's 2.
It's 2. What's n?
N would be 8.
N's 8, p is 2. Easy enough done when it's in exponential form. So the second part of 26 is starting to solve simple log equations. You're probably looking at that going, that doesn't seem to be too simple. But here's the thing. My hint to you is to switch everything to exponential. It might make it easier. So let's take the first one. The first one is log base b of 8 is equal to 3. So, how do I switch that?
B of 3.
B to the 3rd power is equal to 8. So b is equal to 2. You have to use a little bit of intuition on this one, right? When you're solving some of these, you got to know your exponent rules. Because I think if we go across the top and we go to this one now, it doesn't seem to be too bad. It looks like the exact same setup, right? But now it becomes b to the negative 1/2 is equal to 9. Now that's kind of interesting. So the question is now, b to the negative 1/2 power is equal to 9?
81?
Now how did you get 81?
Is that right?
Well, we got to think of this. What does the 1/2 do?
Oh, wait.
It's the same as ever square root.
Okay, it's the same thing as square root. So I think we could all agree that if I took the square root or took to 81 to the 1/2 power, it would be 9, yes?
But it's negative.
Yeah, but it's a negative.
So it's 81i.
Not 81i. What do negative exponents do? What's that?
Move it down.
It moves it to the bottom.
So would it be 1 over 9?
So wait, let's think of it this way. If I wanted to use my exponent rules, how could I cancel negative 1/2 out and get b by itself? Take it to the,
2 over 1.
not 2 over 1, but
Negative 2.
negative 2 power. Negative 2 power. Those would cancel, leaving with b to the 9 to the negative 2. Bless you. Which is 81, but it has a negative exponent, so it goes to the
Bottom, so it's 9
It's 1 over 81. So you notice that I took it one step at a time. I'm showing my work. Bless you. What about the third one? Log base 3 of 127 is equal to m. That becomes 3 to the m equals 1 over 27. Wait a minute. Wait. It just went from a whole number of 3 to 1 over 27. What do you think your exponent's going to be? It's going to be negative. Then you just have to ask yourself, is 27 a base 3? It's 3.
Yeah.
So 3 to the third power is 27, but I want that 27 moved to the bottom, so m is negative 3.
Oh, okay.
You guys catch that? 3 to the third power is 27, but I want it brought to the bottom, so therefore it has to be a negative 3. That is a log of 1/3. P equals negative 2. So that's 1/3 to the negative 2 equals P. Well, that one's pretty easy, isn't it? What do negative exponents do to fractions? Flips them. So it becomes 3 over 1 squared, or 9. Okay. The last one's interesting. The last one you have to use a little bit of thinking. I think most of us, if not all of us, should have gotten here, right? 4 to what power is equal to 8? Well, 4 to the first power is what? 4. 4 squared is 16. So you know it's got to be between 1 and 2. Why is it 1.5? You think it's 1.5?
I think, but I'm not.
Okay. Now let's think of this. We, up in this problem here, noticed that 3 and 27 could both be written as a power on what? I didn't write it down, but we kind of thought it through. 3 to what power is 27? It's 3. And then we said, hey, it had to be on the bottom, so therefore it's negative. Could I have also written this as 3 to the negative 3 power, which is 1 over 27?
Yeah.
And therefore, if our bases are the same, what does that mean about our exponents? So m is equal to negative 3. That's what we got. But does 4 have an exponent that goes to 8, or 8 goes to 4? No. So wait a minute, we have to think about this a little bit deeper and say, is there a number that 4 and 8 can be built from? 2. So wait, 2 to what power is 4? Would you guys agree that 2 squared to the x power is 4x? 2 to what power is 8?
3.
This is power of power. Power of a power, you do what?
Or add. Wait. So, you multiply.
You multiply exponents in power of power. So therefore, 2 to the 2x is equal to 2 to the third. And if the bases are the same, what has to be true about the exponents to be the same? These numbers are the same number. If the bases are the same, the exponents have to be the same. So when does 2x equal 3? divide by 2, x is equal to 3 halves or 1.5. If you're ever unsure, guys, you can check these. Plug it back into the equation. It works. So, we just finished up lesson 26 stuff. So let's go into a little bit of lesson 40 and we'll call it a day. So this one is now starting to get into the laws of logs. Okay? Now, I'm doing this as a little bit of a background. Would you guys agree that 100 is equal to 10 squared? 1,000 is equal to 10 to the third power? Right? And if I was to switch both of these to their logs, you would have log base 10 of 100 is equal to 2. Log base 10 of 1,000 is equal to 3. Can you guys agree with this? Okay. Ten squared times 10 to the third power is equal to what? Using exponent rules. 10 squared times 10 to the third power is equal to 10 to the 2 plus 3, which is 10 to the 5th. So some of this might not be 100% you're going to get because we don't know the rules yet. But maybe a little intuition here. That if I had log base 10 of 10 squared times 10 to the third power, that's going to be the same as log base 10 of 10 squared plus log base 10 of 10 to the third power. But we just showed up above that log base 10 of 10 of 2 is 2. Right? Log base 10 of 10 to the third is 3. And 2 plus 3 is 5. Or log base 10 of 100 times 1,000 is log base 10 of 100 plus log base 10 of 1,000, which again is 2 plus 3, which equals 5. The rule is, if you take a log of numbers being multiplied, you can separate them with an addition. It's kind of cool how that works. That's the rule right there. Sum of logs rule. So what they have here is log base b of m times n. Two numbers being multiplied inside a log. Separate them to their own logs of the same base. Log base b of m plus log base b of n. So what they're going to have you do on this stuff is they're going to have you condense. They're going to have you expand using these rules. There's sum, there's difference, and then there's a power rule. I think we're only going to get through this first rule here. The biggest thing is you can only take logs of positive numbers, so check all solutions to make sure they work. So this is one that you're going to have to solve for. But if you come up with an x that makes a log inside where the 4 and the 6 are, so if you have a number like -5 for x, that'd be log base a of -5 plus 4, which would be a log base a of -1. You can't do that. Okay? So that won't happen. That'd be no solution. It'd be an extraneous solution. So, to do these problems, there's a couple things that we're going to have to take in consideration. Just like on our last problems from lesson 26, that if you had something like 2 to the x equals 2 to the 4th, what's x? It's 4. Because if the base is the same, the two numbers are the same, that means their exponents have to be the same. here's the cool thing. We have logs being taken of everything here. If I can get it to say log base b of x equaling log base b of y, if you're taking the exact same log of both sides and two logs are equal to each other, that would have to mean that x would have to equal y. Because they're logs. If you're taking the log of the same log of both things and they're equal, that means the numbers inside those things are equal. Right? So, our goal then is to get log base a of 4 plus log base a of 6 equaling log base a of x plus 4. And we need to solve it. So to solve it, you need to condense it. You need to write it as one log. So where you see this, you need to write this. You see that the logs are separated here with the plus sign? So what that side going to look like? It's going to be log base a of 4 times 6 is equal to log base a of x plus 4. What's 4 times 6? So it's log base a of 24 equals log base a of x plus 4. Hey, the two logs are the exact same thing. So what does that tell us about the problem then? We can drop the logs or get rid of them and say 24 is equal to x plus 4. So how do you solve that? So x equals 20. So your homework for day 1 is worksheet 1 and a good start on worksheet number 4. Have a great day.